In this video, I'm going to talk about a type of problem that has a nice little shortcut to it that makes the factoring a little bit easier. This type of factoring does not work with every problem. You know, if we have a normal trinomial that looks something like this, like let's say this is minus 3x plus 2, the shortcut that I'm talking about will not work here. So there's a few conditions we need to meet to be able to do this shortcut. Okay, first off, we need to have two terms, and both terms must be perfect squares, meaning that if you took the square root of them, you would get a nice even number. We also need to have a subtraction sign between those two terms, so it needs to be a difference. And we call these problems a difference of two perfect squares shortcut. So when you see one of these types of problems, like for example this problem right here fits all those conditions. We've got two terms, both of them are perfect squares, they've got a minus sign between, then we can use this shortcut. Now, I'm going to work this out longhand first because some people don't like shortcuts, they just like to connect it to what they already know how to do, so you might not even want to use the shortcut. But let's talk about how we would do this. So if I have x squared minus 4, this actually will factor like a trinomial. What's kind of missing here, though, that might bug you, is there's no middle term on this one. There's no x term or b term. What I'm going to do to fix that is imagine that we added nothing in here, or a 0x, and now actually we could treat this like a trinomial. I need factors with our x, one positive, one minus, because of this tells me I need different signs. I would need one plus and one minus, and I would need factors of 4 that would add to give me 0. So I've got 4 times 1. If 1 is positive and 1 is negative, like 4 and negative 1, that gives me 3. And then, oh, we got 2 times 2. If we make one of those negative, yeah, they would actually cancel, 2 and negative 2. So we'll make the 1, 2 positive and the 1, 2 negative. And that, if you checked your smiley face here, that would give you negative 2 and 2x. They would cancel out in those middle terms, giving you a 0. So that's the longhand way to do these problems. The shortcut would be this. So a faster way, or a shortcut for these problems, is we can start by taking the square root of each of these terms. So if we take the square root of x squared, we get x, and if we take the square root of 4, we get 2. And in each of our parentheses, we're going to put an x and a 2, and then what we're going to do is make one of them positive, one of them minus, since it's a minus for the last term. So it would be x plus 2, x minus 2. Let's try it again on this next problem over here. So I've got two terms, they're both perfect squares, and there's a minus sign between. So the shortcut would be, I can square root each of these. This one will be x, this one will be 9. So to factor this a little bit quicker, I can just go right to x plus 9, x minus 9. And I'll leave that to you guys to check these and FOIL them out to make sure that they do actually work. So that would be that shortcut there. Sorry, I'm running out of space. Let's check the next one, 9x squared minus 49. Again, we're going to take the square root of each term. The square root of 9x squared is 3x. And the square root of 49 is 7. So this should factor nicely to 3x plus 7, 3x minus 7. And that would be how we would do this one. Okay, so we met all of those three conditions. Now the next problem you're going to look at and think, wait a second, these aren't perfect squares. Hopefully you're thinking that. So 3 is not a perfect square. You know, nothing times itself that's not some sort of radical expression would give you 3. And same thing with 12. So what we can do, though, if we're paying attention, remember in any factoring problem, we always should be looking for a greatest common factor to take out. And in this case, there actually is a GCF of 3. So I'm going to start by taking a 3 out of both of these. Remember, that means I have to divide each of these by 3. And when I do that, I'm left with x squared minus 4. So this is now a two-step factoring problem, because if you look on the inside I've got two terms. They're both perfect squares, and they've got a minus sign between. So the inside part will now factor, this 4 part, will now factor into x plus 2, x minus 2, just like we did with number 1. That was basically the exact same problem with this first one over here. And we are almost there. Looking at this next one, a common mistake is people might try to factor this into like 4x plus 4 and 4x minus 4, and then they would try to factor that from there because they're thinking square root of 8 is 4. Remember that 8 is not a perfect square. So if you're trying to use this shortcut on this problem, you actually cannot do it. What we would have to do if I wanted to factor this, really my only option is just to take out a GCF here of 8. and if I took this out, I'd get 8x, or excuse me, x squared minus 2 on the inside, and there is no perfect square root for 2. You couldn't put 1 down because 1 times 1 is 1, not, anything like that. Now, in later math classes, there is a way you can factor this with radicals. You could do x plus root 2, x minus root 2, but we're not too concerned with that. We'll stick with integers for today. Okay. And now finally, this last one, you might be looking at this one and thinking, okay, well this works to x plus 2, x minus 2, but let's think for a second. So first off, we haven't met one of the conditions here, that you need a minus sign between to use this type of factoring. And the reason is because if you were to actually factor this out the long way again, if I put a 0x in the middle, first off, the signs would have to be plus and plus. And then we would need factors of 4, we have 4 times 1 and 2 times 2, that are both positive, that give me a 0x in the middle. And 4 and 1 give me 5 if they're both positive. 2 and 2 give me 4 if they're both positive. That doesn't really help me. So in this case, this will actually be prime. You cannot actually factor this polynomial here by any other factoring method. Now, if you use imaginary numbers, there is a way to factor this, but again, that's not a topic I'm going to get into just yet. So again, if you're using imaginary numbers, it is possible, but for this stuff, it's going to be prime. So if you see a plus sign in between, you might have a GCF you can factor out, but if not, it will not factor using the shortcut because it needs to have 2 terms. Both must be perfect squares, and they need to have a minus sign between them. Always, always, always look for your GCF before you try to factor.